So we went over how to find reference angles, but the way that reference angles come in handy is that they allow us to be able to find trig functions of different types of angles. Now, some angles are going to be on our unit circle, and so we might just be able to have them memorized like that, but some angles aren't, and so either way, this is going to be one technique that we can use in order to evaluate trig function. So let's go over a little bit of what those steps are going to look like. So the first step is just going to be to find theta prime. So remember, theta prime stands for our reference angle, so we're going to find theta prime. Our next step is going to be to evaluate the trig function, whatever it may be, at theta prime. And then lastly, we're going to choose correct sign SIGN. So let's look at an example. I have cosine of 4 pi over 3. Now 4 pi over 3 is on our unit circle, and so if you just have it memorized and know what it is, good for you. But we can also use this technique of using the reference angle. So like I said, our first goal is to find our reference angle. So notice that 4 pi over 3 is going to be in our third quadrant, since our numerator is 1 bigger than our denominator. So in order to find our reference angle, we would need to take 4 pi over 3, subtract off that half of our semicircle, which is pi. Again, we have pi, so we need to convert that to a like denominator, and we get pi over 3, which we should have expected because we know since I have a denominator of 3, my reference angle should be pi over 3. So then, the way that we use that is we say, okay, well, because I know that for either one of those, if we were to draw the triangle, they're going to have the same triangle. That means that they're going to have the same trig values. So I'm just going to draw cosine, I'm just going to say cosine of 4 pi over 3 has to be equivalent to cosine of pi over 3. And then that way we really only have to memorize our trig functions for the angles that are in our first quadrant. Well, pi over 3, which is also 60 degrees, cosine is going to equal 1/2. And then our last step that we said was to choose the correct sign, SIGN. And the reason that I say that is because we're using reference angles, which are all acute angles, which are all in our first quadrant. And all of our trig functions are positive in our first quadrant. However, not all of our other angles are going to have positive trig functions. So like in this case, I have cosine of 4 pi over 3, which is in my third quadrant. And I know that sine and cosine have to be negative in my third quadrant. So I'm just going to stick a negative to the front. And that would be my answer. So that was part A. So now let's look at part B. This time, again, they give me a negative angle, which is okay. I'm going to go ahead and start by finding the positive coterminal angle, because to me that just makes the most sense. So I'm going to take negative 210 degrees, and we need to add 360. Which gives us 150 degrees. So then hopefully we notice that 150 degrees is in our second quadrant. So we would take 180 degrees, subtract off 150 degrees, and we get 30 degrees. Now, remember that my reference angle here is 30 degrees, so I know that tangent of -210 degrees has to equal tangent of 30 degrees. Now, remember that if we were to draw us a triangle, we'd be looking at a 30-degree triangle, and we know that my sine is going to be the same thing as my opposite, which is 1/2, and my cosine is going to be the same thing as my adjacent, which is my square root of 3/2. And then remember that my tangent equals y/x. So we would get 1/2 divided by the square root of 3/2, which gives us 1/2 times 2 over the square root of 3. My 2's reduce, so I end up with 1 over the square root of 3. We would need to rationalize that, so we end up with the square root of 3/3. And then we just need to decide if we're in our we said the second quadrant. We know that tangent is going to be negative in our second quadrant, so we need to add a negative symbol. So then lastly, we need to look at part C. So we have cosecant of 11 pi over 4, and hopefully we can kind of already think about what our reference angle might be, but let's go ahead and check ourselves. So notice that 11 pi over 4 is bigger than 2 pi, which means that it's actually going to be larger than 1 full rotation. So we need to find the coterminal angle that's in our first rotation first. So we would take 11 pi over 4 and subtract 2 pi, which is going to be equivalent to 8 pi over 4. Which notice is 3 pi over 4. And from there, we can see, oh, we're in our second quadrant, so I'm going to take I'm going to take pi, subtract off 3 pi over 4. Which gives us pi over 4. So we know that cosecant of 11 pi over 4 is going to equal cosecant of pi over 4. Well, hopefully we remember that cosecant is the reciprocal of sine. Sine at pi over 4 is going to be the square root of 2 over 2. So we need to take the reciprocal of that, which would be 2 divided by the square root of 2. And if we were to rationalize that, notice that we would get 2 times the square root of 2 over 2, which is just the square root of 2. So we know that this is going to equal the square root of 2. And then our last thing we need to decide is if we're positive or we're negative. So we know that we're in our second quadrant, and we know that sine is positive in our second quadrant, which means that its reciprocal must also be positive. So we know that we have a positive square root of 2.